Welcome to episode 2 of the AI for CySec training series. I am your trainer, Hank Hackerson, and in this episode today, we're going to be going over how AI learns and machine learning basics that are very important for us to understand as we go further into the more advanced contents. As I mentioned in earlier episodes, there's actually a book that goes hand in hand with this training series. It goes in tandem with the training series. So if you're reading through the book while you're watching this, or if you're just binge watching all of the episodes on YouTube, congratulations. You've actually got the big picture view of AI so far, and the fact that it can either be a super smart librarian or it could be a super smart assistant, which is the way I like to use it. I use it in both contexts, but I really like using it as a super smart assistant because it can, especially once you leverage it and learn how to really leverage it, it can be extremely helpful and it can make us do more powerful things as human beings. And so what we're going to be doing now is we're going to be cracking the hood, or, going under the hood, going behind the curtains, so to speak, just to see how these things actually learn. And this is a very important concept if you're trying to get into the leveraging of AI for either your own personal life or for work. And this will become one of those skill sets that will be super important as the world of technology or just general industry and the business world starts to adapt more AI into their infrastructure, because teaching AI, right? So if you learn how AI learns, you can then learn how to teach AI, how to train AI, which is the technical term. And if you can learn how to do that, then you will be extremely available in the marketplace. And this is one of the key skill sets that you don't necessarily need to know. You don't have to have the PhD, right? You don't need to be a super technical learner and have all of the underlying code and all of these models and everything like that, but you do need to know how these things learn so that you can ultimately train them and leverage them for whatever it is, the task or the goal that you have through your life and through your business. So think of this specific video and this chapter in the book as your neighborhood tour of machine learning and the heartbeat of modern artificial intelligence. I already introduced myself, so I'm not going to go through this whole spiel at the top as well. But you're going to learn, again, in this video, how AI learns so that we can actually spot the machine learning powering tools that can catch cyber creeps or attackers of various sorts, really, before they can actually swipe your data. And the reason for this is, as the name of the course implies, we're focused on cybersecurity because this whole channel is around cybersecurity and security engineering, pen testing, ethical hacking. So we're going to be getting more and more into the weeds of merging AI with various cybersecurity goals and tools. But if you just learn how all of this works, which is why I'm starting kind of from the very top, right? We're starting general because I want you to understand how it works so that you can actually leverage AI to do anything maybe outside of cybersecurity tasks. So that's kind of the big goal behind why we're taking such a generic, general approach towards the beginning of the training series. And as we get more advanced into the content, we're going to be more honing in more on cybersecurity. We're going to use stories, we're going to use sketches, zero equations, and a quick quiz at the very end of it to just make sure that it sticks. And if you're a paid member, if you're in Hackaholics Anonymous, there are downloadable Jupyter notebooks that have already been uploaded into the shared drive that are available to you that you can actually use as you kind of go through these learning exercises, even while the video is playing or while you're reading through the book itself. But towards the beginning, towards the end, we're just going to do an overview of how it actually works and how it learns so that you can get a good grasp of that, even if you're not a paid member. But if you would like to learn how to become a paid member, a member of the Hackaholics Anonymous membership community, quick little message from Hackaholics Anonymous, and then we'll dive deep into the first section. If you want access to my notes and exclusive downloads and to get lifetime access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers. We have the supporter, the agent, the guardian, and the master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below and you will be able to choose the tier for which you want to join. I really hope I see you in the Discord chats. If not, I hope I see you in the comment section. Okay, so first question is, why does AI even need to learn, right? Why does it need to learn in the first place? So the best way that we can kind of wrap our heads around this is to step away from a technical explanation. So think about the fact that you're teaching a puppy. Now, if you're not a puppy person, I'm a puppy person. I've had puppies all my life. I have dogs sitting right underneath my chair right now. So when you're trying to train a puppy, it's very different from trying to train cats, by the way. It's almost impossible to train cats, although I know a lot of people who have trained their cats. Puppies are a little bit easier to train. So imagine that you are teaching a puppy how to sit. Now, if you've ever had a dog before, then you should be very familiar with this concept, right? So you don't hand the puppy a 500-page rule book on gravity and knee joints and how to bend the knee joints and all of that. So you say sit, right? And then my puppy literally just sat. That's actually super cute. So you say sit, and then you gently push the butt down when it sits, or when you're at first they don't even understand what that word means, so you're trying to get them to correlate the word sit with this action of putting their butt on the ground, right? And then when it actually does happen, you say good sit, amazing, and then you feed the dog a little treat. Then you repeat this concept, and most dogs, for the most part, in one session, most dogs can understand what sit means, because you don't need to repeat this process too many times. You just do it maybe a dozen times, right? That, I would say, the slowest dogs, the dumbest, quote unquote, the dumbest dogs, usually by about a dozen times, they have the understanding that, hey, if I sit my butt on the ground, I'm going to get a treat by the end of all this, right? So they connect those dots. Sit sound, they don't know what it means, but they can register the sound, and then they sit their butt down. Then they get a yummy biscuit or a piece of jerky or some chicken or whatever it is, right? That's what learning is in a nutshell. And you can do this with human babies too, by the way. It's just puppies are like really, it's like the equivalent of maybe a 2 or 3 year old that's just learning these different things. So they don't memorize every if-then scenario, but spotting the patterns from real world trial and error is how learning is done. So how does this actually apply to AI, right? Or machine learning? So traditional programming, you write a bunch of if-then things. So you say, if the email says free money, then delete it, right? That's an if-then series of rules. Very, very basic concept in programming. But hackers can evolve faster than we can update our code. So it may not say free money in the email, right? They have different types of phishing lures that pop up daily. So machine learning flips that script. You feed the AI tool a ton of examples, so thousands of emails. And in those thousands of emails, you will give it, okay, this series of emails are good emails, and in this series of emails are spam emails. And then you say, just sniff out the patterns, right, on your own and try to figure out what are the key details that make these emails spam emails. More than like trying to find good emails, it's more so trying to say, okay, this is the baseline for all the good emails. Now here's a bunch of bad emails. I want you to try to establish your own rule set on why these emails are bad. And it'll learn to flag the fakes without you actually spelling out every single trick that a hacker might use. In cybersecurity, this means that it adapts to zero-day threats. This is a key concept in cybersecurity. Zero-day threats are brand new threats. There is no signatures that have been stored in a database somewhere because somebody saw those threats before. Usually what we rely on with antivirus or threat detection tools is that these tools will actually be referring to a giant database database of signatures that have been attached to either source code or malicious files or something like that, and they detect those signatures. But a lot of times hackers will develop something brand new that does not have a signature in a database, and that is called a zero-day threat. They have 0 days to reply to it because it's brand new, right? And this is a concept that was developed in the military first. So the AI will adapt to these types of threats, which turns your defenses from a lock, like an old, withered down, rusty lock, to a shape-shifting shield that will modify itself. This is kind of like a tongue twister. I love these kinds of things. A shape-shifting shield. Try to say that fast 10 times, right? So machine learning, it's not magic, right? It's technology. It just seems to be really powerful, or it's so powerful that it seems to be magic. And if you went to, let's say 5,000 years ago or something like that, and you had a lighter in your hand, and you flip that little lighter, and then it turns fire in your hand, people did not understand what a lighter was at that time, so they would assume that you're a magician. You have fire coming out of your hands, right? It's not magic, it's just technology, but because of the fact that for the time it's so advanced, it seems like magic. And this is why AI in general, or machine learning in general, seems so magical, because it's so powerful and so complex. But once you understand how it works, it's like, oh, this is just smart statistics that's inside of the code, and then that's trained on data, that machine, the statistics, the code is trained on data, and now it makes predictions based on patterns, right? And just like the puppy, it gets better as time goes on, and you don't need to give it a treat every single time. You just say sit, and it sits, right? So it needs good treats, which is clean data, and patient guidance, which is your oversight, in order for the AI to actually learn through ML, through machine learning. So what we're going to be talking about is tweaking this for prompt engineering and building out APIs and connecting those APIs to a variety of different endpoints and a variety of different tools. But for now, we just need to figure out how the AI learns, right? What are the various types of ways that AI tools can learn? And the way that they learn is in 3 general ways, in 3 flavors, as we can call them. We have the supervised, I can't even speak today, supervised, unsupervised, and reinforcement learning mechanisms, or strategies, we can call it. So it's not one size fits all, right? So there are 3 different ways that you can actually train AI, and you can all do this. You can go create your own AI agent and train it and feed it the type of data that you would want it to learn from, and then you have this customized version of your favorite AI, okay? So the first one, the supervised learning mechanism. So this is the structured classroom. The AI gets labeled examples, like a teacher handing out flashcards with answers on the back of those flashcards. And so this is an example of it, where we say, here's 1,000 emails. These 600 emails are legit, so label them safe. These are safe emails. These 400 emails are scams, and we've labeled them as threats. And then we tell the AI, study the patterns, right? The scammy ones have weird links, or they have urgent language, or they have certain keywords in them, or they have certain attachments, or something like that. And then I want you to quiz yourself on the new emails that come in and compare them against this massive data set that you just received. Now, the reason why this is called supervised is because human beings provide the labels up front. We say that these are the safe emails and these are the scam emails, right? We're not asking it to figure it out on its own. We're telling it, these are all safe and these are scams. Now, I want you to study them and try to figure out what the characteristics of the safe ones are, and I want you to figure out what the traits are for all of the unsafe emails. Going back to our cybersecurity reference with, threat detection antivirus software, if you feed it samples that are tagged as Trojan horse or ransomware or malware or anything like that, and then ask it to spot the resemblances in wild files. So if it actually gets new files that have similarities to these Trojan horses or the ransomware or whatever the virus is, then it'll say, okay, well, you know what? I'm just going to label all of these types of files or these types of software or downloaded executables, whatever they are. I'm going to mark these also as ransomware or Trojan horse because they have a resemblance of all of the ones that I was shown before. And this is technically, antivirus software technically is kind of an AI tool because it's been fed a bunch of data and then it uses that data to make certain decisions. For example, just blocking anything that would automatically be labeled as malicious. And one of the most powerful versions of this is the spam filter that's inside of Gmail, because it actually can, I mean, if you've ever gone into your junk folder inside of your Gmail, there are so many freaking emails that come up. And it's actually really insane because it's like, I mean, I can't believe that they still send out those kinds of emails, because Gmail is kind of, I would say, the industry standard when it comes down to email. And Gmail is amazing when it comes down to the filtering of junk. And I don't think I have ever gotten junk email. I do get email that I think can be labeled as potentially phishing or malicious, but it's not blatant junk email. And the person or the entity that sends me the emails that make it past these spam filters, they know, they're aware that it's like, okay, well, you know what, we're not going to use certain type of language, we're not going to use certain type of formatting and editing, we're not going to include links, etc., all these things, just so we can get past the spam filter and actually end up in the inbox. So that 0.1% of email that actually makes it to your inbox has been modified and formatted with the specific intention of actually making it through, right? So this has been, for Google at least, it's been trained on billions of labeled messages, because if you can imagine how many Gmail users there are and how much email they all get, and then it's been, the Gmail spam filter has been trained on billions upon billions of spam emails that have been labeled as such. And so now it really is very good at recognizing those patterns. So supervised learning is very accurate for threats that are known, because we have a list of threats that we can feed it and we can say these are all bad and these next set that you're getting are all good. So it's accurate. It's probably the most accurate type of learning because we know exactly what is malicious that we're giving it. Now, the con is that it's useless if the messages or the mysteries themselves are unlabeled, right? If they are 0-day type of stuff, because again, we are feeding it data based on known threats. So the analogy would be to teach a kid colors by pointing at red apples and saying red, or pointing at a red card and saying red, right? This is data that we can validate. It's been proven, and it's very easy to actually notice that pattern for that data. The next one is unsupervised learning, right? So we're not feeding it anything and saying this is what this is and this is what this is. Now we're saying here's a bunch of stuff, right? And then you got to go sort through this stuff and try to find your own filtering process for this. So there are no labels on this. And the example, the non-technical example, would be dumping a pile of socks on the floor and asking the AI to sort them by feel alone, right? You're not looking at anything. There are no specific rule sets or anything like that. We're just saying go feel it out and try to figure out which ones are which, right? It'll hunt for clusters or patterns in the chaos, and it'll group similar stuff without any kind of hint. So for network security, for example, imagine scanning network logs. So there's nothing that's been tagged normal or suspicious, but the AI will notice certain clusters. It'll notice that there's a big blob, there's a big blob of pings that happen, like ICMP pings that happen at a certain given time, or they come together in one giant chunk, right? Or there's a weird outlier spiking at 3 a.m., meaning like there's a certain amount of traffic, just a weird series amount of traffic that happens at 3 a.m. from overseas. So it's like in our local time, if the tool itself or the AI has been notified that I'm in Pacific Standard Time, right? So I'm on the west coast of the United States. So for my time, 3 a.m. at my time, most people should be asleep. And so there shouldn't be anybody trying to get access to my network at 3 a.m. So why is there a spike of traffic happening at 3 a.m.? And then the source address for this traffic is coming from overseas. that seems suspicious, right? So just based on that, it's not a specific rule of saying these are all malicious and these are all suspicious, but the previous filtering has been, okay, well, I'm in this time and I'm in this region, and so, essentially anything that's out of this timeline, out of normal timelines and out of my local region, especially if I'm not an international entity, right? So if it's not a website, if it's a server that's supposed to be accessed by my employees that are all on the West Coast, we have nobody else that's working for our company. We don't have remote users. We don't have anybody that would be on the East Coast of America. Nothing like that, right? So we have only people on the West Coast. The IP addresses that you've been assigned that are good IP addresses are all on the West Coast. They don't access our systems outside of normal business hours. So why is something happening at 3 a.m.? And if it is, most likely it's a potential breach that's been flagged, right? Now, this is really handy because there are some things called anomalies. And so when we say deviation from the norm right here, we're talking about a baseline set of activities and a baseline set of traffic, for example. So baseline is normal, right? So if it's baseline, that means it's normal behavior that we expect. And so anything outside of that normal behavior is considered an anomaly. So the unsupervised machine learning or machine learner spots those threats. If it's an insider threat that's outside of normal activity, or if it's a distributed denial of service that could potentially be happening against our systems, all of those things should be relatively easily detected because it knows what the norm is. So as long as it knows what the norm is, it can say anything outside of the norm is potentially an anomaly, and there needs to be an alert generated and maybe even an action taken. And a really powerful version of this that already existed before AI even became popular was a tool called Splunk. And Splunk is probably the biggest name when it comes down to defensive security and alerting and things like that. And it's a SIEM tool. SIEM is SIEM, and it's a security information and events management tool. So it looks at security information, it looks at security events, and it manages those events based on the baseline, based on the normal amount or normal type of traffic that's supposed to be done, the normal type of activity that's supposed to be done. So it'll sift through petabytes of data, literally so much data, hundreds of thousands of log items per day, without any kind of human being involved in tagging a variety of different things, because there's just basic rule sets that have already been programmed into Splunk, and you can even fine-tune those tools, rule sets and tools. I don't know if I said rule sets or tool sets, but I meant rule sets. But there's the inherent native set of rules that comes with Splunk, and then you can even modify and customize your own rules for it, so that anything that happens outside of those rules, then it's been potentially considered to be an anomaly because it's outside of the norm. So the pro is that it's great for unknown unknowns, right? But the con is that it can hallucinate. So one of the things is what? In cybersecurity, we call things false positives or false negatives. So a false positive means that you marked something as positively dangerous, but you did so inaccurately. It was false. It was not dangerous because all cat videos are not necessarily dangerous. So if you group all cat videos as dangerous because of cats or something like that. So it's like that's a false positive hallucination. A false negative hallucination is you mark something as negatively malicious when it was actually malicious. So we consider this to be hallucination in the world of AI. AI can hallucinate. It can come up with things that aren't the actual reality. And this is still, to this day, something that can happen when one of the common examples was they would go and ask any of the AI chatbots, and they would say, why is X, Y, and Z so powerful, right? Or why is X, Y, and Z true? And X, Y, and Z doesn't exist. X, Y, and Z is not true. But the phrasing of the question implies that it is true. And so we're asking it to say, why is it true? And so based on the phrasing of the question, even though its data set says that X, Y, and Z doesn't exist, X, Y, and Z is not true, but the phrasing of the question says, why is it true? So it's going to say, you know what, maybe I just don't have access to that information. Maybe that wasn't a part of my original data set that I was trained on. So I'm just going to assume that it's true because they're asking me why it's true. And I'm just going to make my best guess as to why I think it's true. And that is called a hallucination because XYZ did not exist. XYZ is not true. Therefore, it should come back and say, actually, that's inaccurate. That's false. That thing does not exist. That's what it should say. But a lot of times it'll be like, well, okay, here's why I think it's true, or here's why it's true. And it'll speak authoritatively on why it thinks it's true. And a lot of people will take that information as if it's law, and they'll be like, yeah, okay, you know what? The AI said it, so it must be true. And it's like, well, no, that's actually wrong. And the AI was hallucinating. So an analogy for this would be a DJ is mixing a playlist by vibe, not necessarily a genre label. So spotting upbeat dance clusters from the beats alone, right? So upbeat could be it's 120 beats per minute. And as long as it's 120 beats per minute, it's faster than something that's 90 beats per minute. And so 120 beats typically is around house music. Like let's say between 120 to 130 is house music because it's much faster in tempo. So it's considered to be upbeat. But there's a bunch of different types of music. There's a bunch of different genres of music that actually are between 120 to 130 beats per minute. I used to actually be a DJ. I still DJ. So this is kind of something is very, very near and dear to my heart. And there could be rock songs that are in the 120s. There could be house songs. There could be hip hop songs. So it's more the vibe. And I would say not necessarily the vibe. It would be kind of more considered to be upbeat because playing metal rock music in a party that you've been playing, upbeat R&B or house it can be a miss. It can be a very big miss if that rock song doesn't mesh with the overall vibe of the room. But now we're getting into the technicalities of DJing. The whole idea is that you don't necessarily have to have the same exact genre as long as the upbeat element of it is present. So maybe that wasn't the best analogy, but hopefully you understand what that means. And finally, we have reinforcement learning. So we had supervised, unsupervised, and now we are talking about reinforcement. And this is the playground version, so the trial and error and repeat element of it. So the AI will act in an environment and it gets rewards for good moves. So the puppy getting a treat. It gets penalties for bad moves, so no biscuit, or you kind of tap it on its nose because it peed when in a wrong place or something like that. And then it learns how to maximize those wins over time. And it learns how to look for more wins, for more good moves, for more treats, and it learns how to avoid penalties, right? So there's no data that is being fed into it. There's no data set of labels, I should say, because it's always operating with data, but there's no labeled data that is being fed into it. And it's all about the long game. It's all about just kind of computing and working with a bunch of data over an extended period of time and finding its own patterns. And in red teaming, right, or in any kind of hacking scenario, or whether it's malicious or a blue team type of hacking, where it's like a white hat versus black hat hacking, in ethical hacking scenarios, reinforcement AI learns to probe networks like a gamer that's actually leveling up. It's rewarded for finding vulnerabilities without actually crashing the system. Therefore, it is the most powerful at detecting anomalies. And it's also the most resource-intensive version of the types of learning that are available for AIs in general. Now, there was an example of this that we talked about in the AI history video. So there was a history of AI video that I did, and we talked about the advancement of AI from its initial inception of thought from the 50s and up until 2025, essentially, where I'm recording this right now. And one of the most notable advancements that happened in that history timeline was when AlphaGo beat the Go champion, the Go international champion, I should say. And Go is not like chess, right? So Go is very intuition based. Chess is very rule based. There are however many millions of variations that can exist. However, it's still very rule based. AlphaGo, or Go, I should say, is a game more that is intuition based than it is rule based. It has rules, obviously, but there's a lot of intuition that is played. And a lot of people, I think unanimously, people who have played Go and who have played chess will say that Go is a harder game. So AlphaGo from DeepMind crushed these various pros by playing millions of self games to grok strategy. So to actually generate its own strategy, it played a bunch of games against itself. And in security, in cybersecurity, it powers adaptive firewalls that learn to block evolving botnets by trial blocking and tweaking. So even if it's a successful connection that's being made to your network, if it seems like it might not be a good thing, it might be malicious, then there will be a block that happens in trial scenarios. It'll try to block it, and then from there, if it finds out that it wasn't malicious, then it'll let it go, and then it'll tweak its approach in the future. But it's, again, very, very powerful because it's really, really good at playing at like the billions of variations and looking at all of the possibilities and building a, for lack of a better word, an intuition to be able to do certain types of filtering and analysis. So the handling of dynamic threats is the pro of this type of learning, right? A chess master, right, is kind of another one of these examples. A Go master is another one of these examples where it can actually handle a lot of dynamic real-time changes. So imagine a football quarterback calling an audible because he notices a certain type of defensive strategy being employed against him. And so he's like, oh, you know what? I feel like the play that we originally had planned is not going to work. So I need to go ahead and call an audible. I need to dynamically change the approach that we have so that we can go ahead and make sure that we can get past the defense, right? So this is the same thing here. Dynamic threats that are evolving in real time. They're evolving right now as I'm analyzing this. The threat all of a sudden made a shift, and I need to be able to make that shift along with that threat. I can't go based on heavy rule sets anymore. I need to adjust based on the shifts in the real time of what's happening. The con for this is that it takes a lot of simulation time and computing power, which means it's expensive, right? This is a very expensive type of learning. Relative to when it all started, several years ago, it's getting cheaper and cheaper because NVIDIA just launched a mini AI computer, which is insanely freaking powerful, and it's smaller than my laptop right now, which is kind of crazy to think about. But it's still expensive. It's like a $4,000 computer, you know what I mean? So it's not something that can be taken lightly. And I'm sure that at some point our phones are going to be like supercomputers essentially in the palms of our hands. But until that happens, which is, I don't think it's that far away, honestly. I think it's like maybe a couple of years away. But until that happens, it still costs a lot. And again, so even though it's smaller, it doesn't mean that it's not expensive, right? A $4,000 computer, I would have never thought in my life back when, and I'm kind of dating myself right now, but when I got my first computer, it was in the early 2000s, and it was a weak ass computer. It was like a very weak computer, and that computer cost a lot of money, and I couldn't even imagine that I would be one day I would be buying a $2,000 computer, or not even that, I would be buying a $2,000 phone. You know what I mean? Like the phone that I have now is 10x, 100x more powerful than the very first computer that I ever bought. So it's really insane to think about how quickly these things are progressing. But even with all of that, even considering all of that, it takes tons of computing power and simulation time for an AI tool to be able to do what some of the more advanced reinforcement types of AIs can do. So the analogy here would be your kid is learning soccer. The kick towards the goal is a score. A foul is a penalty. So you keep doing this trial and error until you've learned that, oh, I shouldn't commit a foul, right? I shouldn't be, checking somebody's shins and trying to purposely injure them because I'm going to get punished. They're going to get a free kick, a penalty kick, and they're going to potentially, it's like the highest statistical way for them to score. So it's like, okay, well, shit, I probably should not have done that. I should try to play within these guidelines of these rules to try to score these goals and get my reward, and the team is going to lift me up and I'm going to be super happy about it, but I can't try to break somebody's shin in the process. So that's reinforcement learning, right? They go through that until they become proficient, prolific soccer players. So these rules aren't silos, right? So real AI actually mixes these things. So, dealing with Grok AI, for example, Grok AI already has been trained on I don't know how much data, and it's still very, very proficient with its structured and unstructured learning. But then it also needs to have reinforcement learning. Every time it talks to you, every time you interact with it, it needs to learn more about who you are and the project that you're working on, what you're trying to accomplish. And one of the things that was very interesting that I found out lately is that, the power of the AI, the compute power that is fed to the AI will change based on what the user uses. So if I go to it and I say, here's this giant Excel sheet, it has 1,000,000 lines on it, and I want you to sift and sort through this, right? And learn how to give me this, series of data points from this massive file, okay? That's the way that I would use it. And then somebody else goes to it and say, hey, I want you to write me an essay that is 500 words long. And I want you to write it about apples or something like that. Why apples are so sweet and why we should be including them in pastries, right? That is noticeably a much less complex version of using that tool, and it'll definitely do it. But if that person goes and says, okay, now write me one about bananas and write me one about peaches, and then they generate 5 or 10 or 20 different prompts that are asking low complexity types of tasks from Grok, then Grok is going to start limiting itself. It's been designed to distribute its computing power to the most complex users. So after a while, it will actually tether itself, and it'll actually not use as much computing power if it thinks that all you're going to do is ask it to give some basic ass responses. And then I'm going to ask it to analyze massive files, and I want you to go ahead and look at these malware files, or I want you to go ahead and look at this source code for this thing and tell me how we can improve the source code for this application to make it run faster. Like there are a lot of different complex goals that you can give these AI tools, and if you don't use them in that manner, they'll tether themselves, right, based on the interaction that they have with you. So it's a mixture of these learning types. So supervised for training, reinforcement for tweaking, and real-time adaptation. So what we're going to be talking about in this training series in general is when we create hybrid agents, as we get to chapter 17, or I should say episode 17, by mastering the basics and setting you up for no code wins, which is going to be something that we're going to cover in the very next episode, because there are a lot of tools that already exist that you can use without having any coding knowledge whatsoever. And it's already been uploaded into the Google Drive for our Hackaholics Anonymous members. There's a massive list of tools that you can actually get access to by simply getting access to that list that we have that you can use for a bunch of different things. And honestly, if you don't want to wait until that episode, or if you're not a paid member of Hackaholics Anonymous, you can just go Google it and you can say what AI tools are available for, and then just fill in the task that you have in hand. Whether it's for image generation, whether it's for coding, whether it's for website design, whether it's for robotics, or anything in between, right? Anything else that you're trying to do, there are tools that are available that can be used specifically for those tasks, and as well as cybersecurity, right? What AI tools already exist for cybersecurity? And then just go ahead and use them without having to know anything about code. So it's a very, very, very interesting world, and it's continually, by the minute, it's getting even more interesting inside of this world of machine learning and AI. All right, now we pivot a little bit, and we're going to talk about the pipeline, the machine learning pipeline. And it's a series of steps that take place, an assembly line, so to speak, that can turn raw data into a working model. So no whistles or anything like that. There are just going to be 4 stages that we need to worry about, 4 stages that anyone can really follow. Number 1 is it all starts with data. So you collect and format and prepare your data. And we can refer to this as the ingredients of what we're trying to accomplish. So you gather all your ingredients. In cybersecurity, that means network logs and application logs and authentication logs and security logs and a variety of different emails, or even packet capture from network sniffing tools, right? From things like Wireshark or TCP dump. Then you clean up the error. You parse through it. You fix any errors that might be inside of that data. Anonymize sensitive bits. So, for example, if you're dealing with the General Data Protection Regulation, which has to do with essentially any website at this point, because as long as somebody in California lands on your website, the website could be in the UK, right? If somebody in California lands on your website, then your website needs to abide by the GDPR regulations. So there's sensitive bits of data that every user has that, for example, I don't know, maybe their IP address or their email address, whatever it is, whatever the sensitive data is, it needs to be anonymized. It needs to be anonymous, right? So nobody that might be capturing that traffic can actually figure out what that person is up to or who they are at the very least. And diverse data in this particular case equals smart AI. So if you have biased data, then your AI is going to be biased and your AI is not going to be as functional. There's going to be blind spots in the AI's abilities. So training on US only traffic will miss global issues. So if you're saying, yeah, I just want you to worry about the United States traffic, it's like, okay, cool. It'll be good at United States traffic. But if something happens in Bangladesh or if something happens in Europe or in China or whatever, your AI is going to come up lacking very badly. So the diversity of data is excellent if you want to have the most intelligent AI model possible. Once you've collected all of your data, now you need to train the model. So you feed all of that data into an algorithm. So the recipes that we talked about in our very first episode. Once you've done that, so you can have supervised learning, right? You can actually label the data itself and say, okay, this is the types of data that you have. This type is good. This set is bad. And then you let it practice its predictions. And then anytime that it practices, it can tweak itself and optimize its performance based on the errors that it makes. So it'll adjust its weights, right? But assuming, and weights is actually something that is applicable directly to AI jargon and AI language. It's not just something that's only for gym repetitions. There is something called weights when we're talking about AI training. So the internal knobs that are relevant to the AI's capacity are adjusted until the accuracy peaks, until it gets to the most accurate, for example, the 99.9% that Google spam filters go through. So it's like a scikit to learn and handle this under the hood, right? Scikit is actually a tool that's available that can work under the hood of this AI, and we're going to be talking about it as we go further in our trainings. However, these are the things that you actually are going to be using code with. So these are not the non-code. When we say section 3 right here, we're not referring to episode 3. We're talking about the section 3 content, which is going to be in a probably half a dozen videos or something like that. So, but that's basically it, right? You collect the data and then you start training the model. And then the next step, you test and validate the training. You test and validate the learnings, right? So you've trained it with as much data as you can, and then you go ahead and train on 80% that is available, and then test on 20% that is actually real data from the live activity that's going on, right? You do all of this because you don't want to have a half-baked cake, which is basically, imagine if you've ever eaten anything, any kind of pastry that wasn't fully baked, you're eating like mushy dough, and it's like a very weird type of a texture. It doesn't taste right. You don't get the full experience of the pastry because it's half-baked, right? And we can also refer to the Dave Chappelle movie, Half-Baked, as well. But they were fully baked in that movie. If you know, you know. The metrics like precision, for example, meaning that there aren't too many false positives, right? There aren't too many false alarms. Or recall, which meaning catching all of the real threats in real time, maybe in a dynamic environment. they gauge the fitness of the AI. So this is where testing and validation actually comes in, and this is before you deploy and monitor. This is not different from the software lifecycle when you're actually going into the security of the software or the functionality of the software. It's very similar to what we would do, because before you actually monitor, my dogs are going crazy in the background. They're like fighting and play fighting each other. Before you actually monitor or deploy, before you actually deploy the tool and start using it, before you deploy the application, the software, and start using it in a real live environment, you need to first test it and make sure that it's good in as many controlled environments as you possibly can. And then you will deploy it and you go into production. And then while you're in production, you go live and you monitor everything, right? The model will infer new data. So real-time threat scans or real-time user data, how users end up using it, and then making adjustments and analyses and observations based on all of that data. And it's never set it and forget it. The work is never done. We just go back to the beginning, right? So it's like you go back to the beginning of the assembly line, so to speak. It's like the live data, this real-time data that comes in, goes and gets organized, and then it's fed, and then there's training that takes place on the live data, and then there's testing, and then there's more monitoring that goes on, and then more data is accumulated, and then that data goes and is fed into it for training, etc., etc., etc. So this is not a set it and forget it. It never will be, right? Nothing in technology is set it and forget it. If you assume that this is what you can do, then you will be blown out of the water by your competitors very quickly, or if you're inside of the security environments, you're going to get hacked very quickly. There is no such thing as set it and forget it. Just keep that piece in mind, okay? There's going to be retraining that's done regularly. There are updates that are done regularly. Mutation of threats is a very real thing, because there are AIs that are used for generating threats. There are AIs that are used for penetration testing and hacking. So all of those things are constantly evolving the threats. Think about the very first version of the flu and how quickly or relatively easily we can fix it now. And so the virus of that is now evolving because it needs to still do its work while you go ahead and take TheraFlu or whatever it is that you need to take. So there are services like the AWS SageMaker, which actually make this plug and play, meaning the deployment and the monitoring and the retraining are plug and play. You don't need to know too much about the source code and everything like that. You can still pull this off by using a tool like SageMaker. And so this pipeline that we're talking about, if you're interested in training AI, if you're interested in building your own AI and training your own AI models, this is as close to a superpower as you can understand. And it's not complicated. It's just 4 steps, but a lot goes into these 4 steps. There's a real case that happened, and this was for a fraud detection situation that happened at a bank. There was collected transaction data, and they trained a supervised model, a supervised AI based on that data. They tested it on holdouts, and then they deployed it to flag $10,000 anomalies. And as a whole, based on all of the anomalies that they found, they saved millions of dollars. So this is very real. It's being used all the time. And this was before ChatGPT. Like, supervised AI models are not just recent in the last 2 or 3 years. They've been around for a very long time. So, I should say relatively, but they've definitely been around for like over 10 years, easily. And supervised training for these AI models has been around for a very long time as well. So the notebook that we have to simulate it is going to be with what you're going to have available towards the end of this whole thing. And it's basically the, oh my God, I forget the name of the tool, but it's a Google workspace or Google notebook that's done in, gosh, I can't think about it right now, but it's already done. It's already done. It already exists on our Google Drive for Hackaholics Anonymous, and then we're gonna go review it in a few minutes itself. But it already exists, and then you can modify, tweak the data that you want to actually watch the model learn in real time. All right, before we jump into the wrap up, we want to kind of, I guess, reinforce this concept, right? Because this is something that I have said already in this training series, and we're probably going to refer to it again, right? There's a reason why machine learning is so powerful in the security context, because threats, right, malicious actions that are being done by malicious actors, also known as hackers, right? These things aren't static, they're constantly evolving. So we talked about the statistic early on that there are 2,200 daily attacks that are being mitigated, or at the very least detected, by AI tools. And machine learning makes the tools that we are using evolve as these threats evolve, because for a human being to try to keep up with all that stuff and try to hard code the updates to these various tools, it's impossible, because the threats are evolving too quickly, too frequently, and too powerfully. So it just can't happen for a human being. The human can't do it anymore. And it's been like this for years, by the way. This is not something that, again, it just happened over the last few years and people are freaking out about AI. It just became really commercial, and a bunch of people are using it over the last few years in forms of these chat bots like ChatGPT or Grok or Google Gemini, whatever it is. People are just using it on a more commercial level, but these things have been around for a very long time. And these tools are being trained for a very long time because security has been an issue for a very long time. So it's not something that was readily available to the consumer public, because the consumer public didn't really care at the time. It was more enterprise environments and giant companies that had to account for all of the attacks that were taking place against them. And so they needed to develop the tools that could keep up with all of those evolving threats. So supervised training shines in malware classification. For example, the VirusTotal AI that tags file types. VirusTotal is something that we use frequently. It's a website, basically. And you can go in there and drop a link inside of their little search bar and see whether or not that link is malicious. And it has this giant database of various antivirus tools and a lot of security tools that have their databases shared on VirusTotal. And so VirusTotal can tell you whether or not a link is malicious, whether or not an attachment is malicious, so on and so forth. So it has its AI that sifts and sources through the signatures of the files, or it looks at this giant database of malware URLs, whatever it is, and it uses its functionality and its data set to go ahead and tag the various file types or the URLs or hash values for files that can potentially be malicious. Unsupervised learning uncovers those stealthy, advanced, persistent threats that are lurking in logs. And there are APT groups. So these are groups that are attacking an entity over a span of years, right? Not just a couple of days, couple of weeks, or a couple of months. They're attacking. I mean, it happens against the United States. For example, countries have advanced persistent threat groups that they fund with government money, and the sole purpose of these groups is try to hack into the servers and the systems of other countries. So this is not something that happens over a span of just a couple of weeks or a couple of months. It takes years, and so they're constantly attacking. These 2,200 daily attacks are not just a small number of attacks. There's a lot of attacks that happen regularly, and a lot of them happen against countries and very large companies that hold a lot of money or hold a lot of data, and it would be in the benefit of the attacker in the persistent threat group to take down that company, because if they take down that company, then they make a lot of money as their competitor, or I don't know, their goal is achieved, whatever it is, whatever their reason would be for trying to take down a giant company. Reinforcement learning is training hunter bots to learn to chase simulated hackers in virtual nets and do it in real time. This is as close to real time learning as possible. And it's something that happens in a dynamic type of an environment. And all of these things are extremely useful for security, cybersecurity, physical security, robotics, etc. They're extremely useful because, as we've talked, probably a dozen times, AI can simply just do things that human beings cannot do, and it can learn much faster than we can. Therefore, it has more powerful functionality. It can't do it by itself because it needs to be fed data and then it needs to be fed instructions. So as it stands right now, it needs us for it to even be able to do what it does. It needs the data that we give it for it to be able to do what it does. But it can do it extremely well. But even with all of that being said, there are still pitfalls even to this day, and they will most likely always be pitfalls, because overfitting, or for example, memorizing a bunch of training data and then flunking those tests, is very similar to cramming for one specific exam and just over preparing on that, and now you are lacking in other areas. Or adversarial attacks, where the actual hackers poison the data to fool the model, right? This is as old as time. Well, not really as old as time, but it's a saying. You know what I'm saying? It's something that has not recently developed. It's something that has been existing for a very, very long time. And if we know how AI works and how AI learns, all we have to do is just give it bad data, right? It's no different than giving it biased data and saying, yeah, this is the world, right? And then it's like, okay, well, this is just the world from Hank's perspective, so that's definitely not the world. So that could be poison data, because my perspective on the world could be absolutely skewed and incorrect. And I'm saying that this is the perspective of the entire world. So that could be poison data. But then there's obviously malicious data. There's like malicious poisoning that can be done to data, and then you feed it to the model, and now the model starts doing certain things. So for example, tweaking pixels to bypass image scanners. That could be something that you can train it to do. So we're going to be talking about this in future videos, but we can always audit for bias, like a machine model over flagging diverse user logins. That could always be a very easy way to start, like a good first step. And then another way to actually kind of practice with this is something called the teachable machine. So a teachable machine is a no-code tool from Google that you can learn to train, as the name implies. And this is the teachable machine. So you can actually train a computer to recognize your own images, your own sounds, and various poses, and it'll do so extremely well. And there are a lot of different organizations and entities that actually do it. And probably the best way to show you the examples would be by looking at this little section on the right here. So if we zoom in right here, there's the tree pose and the wing pose. There's the difference between a clap and a snap. Whether or not something is marshmallow or it's not a marshmallow, whether or not the dog is on the screen or you're on the screen or you're there with the dog, right? Whether or not the music itself is metal or non-metal. And then here's the original thing with the tree pose and the wings pose. And so this is just a couple of examples of this. And you can go ahead and use your Google profile and just log in and actually start using this model. And it's very, very simple. You build a few different classes of data. So for example, 2 different classes of pictures from your puppy. You gather all of that data, and then you feed it to the model, and then you click train. And it starts actually training it and learning instantly whether or not it can correctly classify new examples. And then you then export your project as a new different source of data. And then you can reuse this and repeat the cycle over and over and over. So you can do it with images, sounds, poses, etc., a bunch of different things. Obviously, they have tutorials that are available for you. So this is like one of the coolest ways that you can test AI models and how to train AI models without knowing code at all. And this just by itself is an extremely powerful little resource. And if you're curious about this kind of stuff, I highly encourage you to practice it. All right, as a wrap up, let's do this quick little quiz right here. So without, scrolling back, right, without going and re-watching the video first, see if you can just answer these. They're not complicated questions. I just want to know if you paid attention and you were retaining the information. So what's the main difference between supervised and unsupervised learning? So if you could just think about that real quick, you can jot it down, obviously, but just kind of grade yourself, right? Give a cyber example of reinforcement learning, cyber being cybersecurity. True or false? Machine learning models never need retraining. That one's pretty obvious. In the pipeline, right, in the machine learning pipeline, what is training? What is considered training? And keep that in mind as well. So if you scored between 3 and a 4, then you're pretty solid. If you scored below 3 and a 4, basically 2 out of 4 or below, then you should kind of rewatch this and pay attention to what we talked about. And for Hackaholics Anonymous members, we do have our downloads. So we have the interactive Jupyter notebook, for just machine learning simulations. This is on Google Colab, and there's no local install that's needed. So you can just run this from Google Colab. And there are different ways that you can just modify the data just so you can see how the AI actually learns. You'll find the source code that's inside of it as well, and you can just kind of mess around with it. My recommendation is if you want to mess around with it, download your own version of it, and then mess around with the source code as much as you possibly want, so it doesn't mess with the master copy that's available for all of our members. There's supervised learning that's available on a toy data set, so classifying fruits from images, for example. Unsupervised learning cluster of network traffic to spot outliers, and a basic reinforcement game where an agent learns to avoid threats through rewards and penalties. Each of the simulations has explanatory markdown cells, so there's explanations for everything basically. Sliders for tweaking parameters, so if you wanted to just modify to see how the response is going to be. And cybersecurity tie-ins, so this cluster will work in your anomaly alert, for example, right? And finally, there's a one-page guide on forking and sharing your results in the community. And there are going to be several other downloads that will be by the time that you see this video as well. So there's going to be a bunch of different things that are available for you. And this is all available through the Hackaholics Anonymous membership. So if you're curious about that, here's how you join. If you want access to my notes and exclusive downloads and to get lifetime access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers. We have the supporter, the agent, the guardian, and the master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below, and you will be able to choose the tier for which you want to join. I really hope I see you in the Discord chats. If not, I hope I see you in the comment section. If you got value out of this video, and if you would like to get more videos like this one, then I encourage you to like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out on this channel, whether it has to do with AI for cybersecurity, whether it has to do with penetration testing, or anything else in between, really. And then you can go ahead and drop a comment if you have any questions about what we talked about today, or if you have questions about some other kind of stuff that you're dealing with in this world, right? In the world of AI, cybersecurity, tech, computer science, all that. And of course, go ahead and check out all the content that already exists on the channel. There's a bunch of different playlists. There's currently over 440 videos that are live right now. By the time that you watch this, there's going to be even more videos that are going to be available. So there's content that's constantly being uploaded, multiple uploads per week. They're going to be in different categories. We're getting a little bit more diverse with the content. And there's a bunch of things for beginners. So if you haven't already gone through it, there's a bunch of different playlists that are actually available, including, for example, the Cybersecurity 101. Where are the playlists? Here we go. There's the Cybersecurity 101 is a really big one for people that just don't have a background in cybersecurity, right? And if you're just trying to get an understanding of what the world is like in this realm and how to get started, where to go once you've established your foundations and your basics. And there's a bunch of other stuff, the CompTIA Linux Plus playlist, all the CompTIA stuff people have actually used to pass their examination, and there's a lot of stuff. So I'm not going to beat a dead horse here. I just want you to go and check it out and learn about everything that's available over here. And there's the community posts, and there's a lot of stuff. So if you have not done so already, make sure that you like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease. And I will see you in a next video later.